Today our topic is dimensional formula. So in the last class you have seen the fundamental physical quantities. We have seven fundamental quantities like mass, length, time, temperature, electric current, amount of substance and luminous intensity. Now every physical quantity we can express in terms of certain symbols of these fundamental quantities. So for these seven fundamental quantity we will assign a few symbols. In terms of these symbols, we will express every other physical quantity. And such a formula is called a fundamental formula. Dimensional formula. So, first we want to see which are the symbols which we assign for each fundamental quantity. So, I will explain the symbols first. For mass, the symbol which we express is capital M. Then for length, we will use a symbol L. Time, we will use capital T. Then for temperature, we will use capital K. Then electric current, we will use a symbol capital A. Amount of substance, MOL is a symbol. Then CD for candle. These are the symbols of seven fundamental quantity. In terms of these symbols, we can express every physical quantity, and that method of expression is called a dimensional formula. Okay. So we'll see a dimensional formula of a few physical quantities. And we can start with the speed. Speed is a speed is a derived quantity, it's a physical quantity. So we can see first one speed. So what is the equation for speed? Speed is equal to distance divided by time. Okay, distance by time. Now distance is the length. Distance is length. Length has a dimension symbol L. I'll give the symbol L. Time, I know the symbol, it is T. So L by T. Now we will express the denominator we will take to numerator side. You will get L T raised to minus 1. When T comes up, it will become T raised to minus 1. Now we don't have mass here. Actually, when we express every physical dimension formula, minimum it's a usual procedure that we will write a symbol of mass, length and time. Here we have a symbol of length and time. We don't have mass. What we will do? We will write a symbol of mass also. But m raised to 0 we have to write, because here actually we don't have mass. But we need to give the symbol of mass. How will you express it? We will write m raised to 0. Then put a square bracket. This is the dimension formula of what? Speed. Okay. Now next we will write velocity. Second quantity we will write velocity. How will we write velocity? Velocity has an equation. Displacement by time. Displacement divided by time. Displacement is also having the dimension of length. It's also a length. So we can give dimension formula L, then time T. So you will get the same dimension formula. Displacement, for displacement we will give capital L. For time we will give capital T. L by T. So it will be m raised to 0, L T raised to minus 1. So dimension formula of a velocity and speed will be the same. Okay. Now similarly we will see a few dimension formula. Third, you can see dimension formula of acceleration. Acceleration. So we know that what is acceleration? Change in velocity by time. Or simply we can take velocity by time. Change in velocity by time or velocity by time. So equation is velocity by time. Velocity by time. Now, if you already know dimension of velocity, directly we can substitute. Otherwise, what will you do? We know we need to remember the equation of velocity. So that method I will explain. Otherwise, you need to by heart all the dimension formula. It is practically impossible. So do one thing. You are supposed to know the equation. If you know every equation, then easily you can find the dimension formula. So velocity. What is velocity? Velocity is displacement by time. So write in that term. Velocity is equal to, you will write displacement divided by time. Then this time is in the denominator side. This time also comes in denominator. How will you write? Displacement divided by time into time. It will be time square. What is dimension symbol of displacement? Length L. For time we have capital E, but we have to write T square. So when it comes in numerator T square, you will get L T raised to minus 2. But we have M also, M raised to 0. This is the dimension formula of acceleration. Okay. Next we will see dimension formula of force. We can dimension formula of force. We know that force is equal to mass into acceleration. Mass into acceleration. Now we will write dimension formula of mass. First you expand this. Mass into, what is acceleration? Acceleration means change in velocity, or simply velocity by time. Velocity by time. Okay. Now mass into, what is velocity? I can write time I will take here. This time I will take along with the mass. Mass by time into, what is velocity? Velocity is equal to displacement divided by time. Velocity is displacement by time. So what is the dimension formula? Mass we have m, displacement L. Now denominator we have time square. So how can I express the formula? For mass we will give capital M, displacement we will give L, then time square. When it goes upwards it will be t raised to minus 2. Denominator we have, denominator we have time square. So t square is a dimension formula. When it comes in the numerator you will get it is t raised to minus 2. Okay. So ml t raised to minus 2 is a dimension formula of force. Next we can write dimension formula of electric current. Electric current directly we are knowing. Electric current has a dimension formula capital A. Okay. So electric current. Electric current. How will the dimension formula? We have only A. So we have to express m raised to 0, L raised to 0, T raised to 0. So usual procedure to write the symbols of minimum, mass, length and time. So current has the dimension formula. Sixth one we can write electric charge. Electric charge. To write dimension formula charge, we have to know dimension equation of charge. We know that charge Q is equal to current into time. Okay. So what is the dimension formula? Current has dimension formula A. Time has dimension formula capital T. And we don't have a M and L. What will you do? You will write M raised to 0. Then we will write L raised to 0. So that's the dimension formula of electric charge. Next we can write work. Dimension formula of work. And we know that work is equal to force into displacement. Force into displacement. Force is equal to mass into acceleration. Mass into acceleration. Then into displacement. Okay. Now again we can split the equation mass. What is acceleration? Velocity by time into displacement. Now I will take mass, displacement, time together. Mass into displacement divided by time. Then what is velocity? Velocity is equal to displacement by time. Now we can write a formula, symbol, mass. For mass we have a capital M. Then displacement, displacement square. Dimension formula is L square. Numerator, denominator we have time into time, time square. When it comes up, dimension formula is t raised to minus 2. This is the dimension formula of work. So in this manner we can express every physical quantity. So here we have expressed 7 quantities. Speed, velocity, acceleration, force, electric current, electric charge, work. In the same manner we can write every other physical quantities in terms of the dimensional formula. So dimensional formula is an easier method of expressing every physical quantity using the symbols of these 7 fundamental quantities. Okay, thank you.